Right now, at a distance of over 24 billion kilometers from Earth, a man-made object is flying through the interstellar void. It is humanity's furthest outpost, Voyager 1. But here's the crazy part. This machine is running on technology from 1977. Its computer has a clock speed slower than your car S key fob. It has a total memory of just 69 kilobytes. To put that in perspective, a single GP image of your cat is about 50 times larger than Voyager's entire brain. So, how did a machine with less computing power than a pocket calculator manage to leave the solar system and survive for nearly 50 years? Today, we are looking at the ultimate engineering miracle. In the 1960s, NASA discovered a rare alignment of the outer planets, Jupiter, Uranus, and Neptune. This alignment only happens once every 176 years. It was a now or never moment, but there was a problem: fuel. To visit all these planets, they needed more speed than any rocket could provide. The solution? Gravity assist, or as we often call it, the slingshot effect. Voyager didn't just fly past Jupiter. It stole a little bit of Jupiter's momentum to fling itself toward Saturn. It was a cosmic game of billiards, calculated with punch cards and mainframes that took up entire rooms. As a programmer, this is the part that blows my mind. Voyager runs on 3 dual redundant computer systems, but the hardware is fragile. Imagine debugging a system where console log takes 45 hours to return the result. That is the reality for the Voyager team today. A radio signal takes about 22 and a half hours to travel one way. In late 2023, Voyager 1 started sending back nonsense. It looked like the end. But the engineers didn't give up. They found that a single memory chip had failed, corrupting a section of the flight data subsystem. They couldn't go up there to replace the chip, so they did something incredible. They wrote a software patch in assembly language. They broke the code into chunks and stored them in different non-damaged parts of the memory. Effectively, they performed a memory transplant, IRELESLY dot dot, across 15 billion miles. And it worked. The probe came back online. This is the ultimate example of remote debugging. In 1990, as Voyager 1 was leaving the planetary neighborhood, astronomer Carl Sagan suggested turning the camera around for one last look at Earth. See that dot? That pixel caught in a sunbeam? That's us. That's home. Everyone you love, everyone you know, everyone who has ever lived out their lives on that mote of dust, suspended in a sunbeam. From Voyager's perspective, our wars and our borders are invisible. It reminds us of our responsibility to deal more kindly with one another. Voyager's nuclear power generators are dying. Sometime around 2030, it will go silent forever. But it won't stop. It carries a a message in a bottle for anyone who might find it. It will drift in the Milky Way for billions of years, long after Earth is gone. It is, quite literally, humanity's bid for immortality. If you enjoyed this story of code, space, and exploration, make sure to hit that subscribe button. I'll see you in the next one.